Give the heading rate of change.
This is in differentiation.
Yes, obviously. Differentiation is a very big chapter. That's why I was trying to make some compensation from that topic. And this is an application. This is an application of differentiation. This is an application of differentiation. So make the first concept in this topic. The first concept is coming. The term rate means something is changing with respect to time. It's a concept of physics actually. And when you divide something, when you divide something from time, so when you divide something by time, it is called rate of change. So can you please copy this?
Done.
How we write rate of change? Remember that something is divided by time if the denominator is dt. If the denominator is dt, it is called rate of change. There are different rate of change in our course, like rate of change of y, rate of change of x, rate of change of radius. So you will identify them from the unit. You will identify them from the unit. Have you done physics before, or you're doing accounts, commerce system?
No, I done physics before.
Okay, that's good. So you can easily identify the unit: centimeter square, centimeter cube, centimeter per second. So
Yes.
these are the physics units which will help you to identify that is it the area, is it the volume, whatever it is. So you have to know. Now you have to copy this screen.
Done.
So these are the important rate of change. There, the units are coming from physics. Now, for an initial value, this is again a concept in physics that when you start an experiment, the time is zero. So when we differentiate something with respect to time, it is called rate of change. You have to copy these two concepts.
Done.
I'm showing you an example. I hope now you remember differentiation well. I hope you remember the differentiation. Y is equal to t square plus 3t plus 6. When you differentiate a number, look at the screen, please. When you differentiate a number like 6, that number always becomes 0. Otherwise, the simple variables will become 1. So now you have to copy this example. Carefully see the denominator is t.
Yeah. Okay. Done.
When you are differentiating with respect to t, the denominator will be carrying t. This topic is called rate of change. As mentioned earlier, differentiation is a big chapter in P1, and it is containing some subtopics, subunits. A ratio method can also be used to find the rate. What is the ratio method? For example, one pen is costing 10 rupees. So two pen will be costing 20 rupees. This is called ratio method. So look at the example. For example, radius changes by 10 centimeter in a time of 2 seconds. Radius changes by 10 centimeter in a time of 2 seconds. So I can make it a ratio directly. Look at the screen.
Done.
If rate of change is positive, if your answer is positive, rate of change is positive, it means increase. And if rate of change is negative, it means decrease. We have to copy these two important concepts.
Done.
Now, I had shared with you a file selected exercises from O-level ADMAS book. This book, okay? I hope you can open it if you want, if you are having a secondary device with you presently. Exercise 16.1, this is ADMAS book. Some selected questions from ADMAS book are very helpful. Remember, ADMAS is bigger than P1. So ADMAS is nearly touching the A2 maths. So you're not supposed to do any other extra questions. Whatever extra time you get, please give it to the past paper. The radius of a circle at time t second is given by r is equal to 9t minus t cube. At each of the following instants, find the rate of change of the radius and state whether the radius is increasing or decreasing at instants. So now you have to read the question, give the reference, again, do a separate register for questions and keep one register for notes.
Shall I solve this exercise?
Yes, read the exercise number, refer to exercise number 16.1, write ADMAS book and see the question number 1. No need to copy the question, just read the question and copy the equation. Have you read the question?
Yes, sir.
Okay, now
I'm solving it.
good. Copy the question and as a habit, make some working like this. First, make the data. Examiner wants rate of change of R, rate of change of radius,
So the first part is 8. I think it's increasing. And the second is 10. And the answer, it's also increasing. For the third, I didn't copy the question. What was it?
leave it. What is your first part value?
The first part value is 8.
Look at the screen. I'm getting 6. Check it.
Yeah. Okay. So yes, it's 6 centimeters.
Now, join question number 2. Question number 2. The length of an elastic string at time t second is given by this equation. find the instant, that is the value of t, when the length is increasing at a rate of 5 millimeter per second. Copy the equation. First read the question, then copy the equation.
Sir, what is your answer? I just have to confirm.
First, the rate of change of L is 5.
Yeah, I got the same answer.
So this is the point here, and you have the file. I have sent you the file, and look at these 3 questions. Please mark them for homework. I'm sending you the homework, but by now you haven't shown me any homework. So please try to share some of your solution. What are how you are solving the question.
Sure, sir.
Let me post this also, and you can note it on your own. But do not do other questions, because this book is not for P1. Originally, this book is for AdMass, and definitely AdMass is a much bigger course than our P1. You have to do later 3, 4, and 5. And this will be Now give a new heading in your notes register.
Okay.
The name of the topic is maxima and minima. This topic need some memory of O-level maths, O-level maths mensuration questions. I will share with you the formulas, and you need only formulas, mensuration formulas, O-level maths, and you have to remember it for solving these questions here. These are diagram-based questions, and within differentiation, this is the most challenging topic. Now, maximum and minimum values. What is this concept about? This concept is about the functions. Whenever you are talking about a differentiation, you can differentiate a function multiple times. When you differentiate a function first time, you get dy upon dx. But when you differentiate a function second time, you get d2y upon dx2. This is called second derivative. You have to copy this in notes.
Done. Done, sir.
For example, look at the screen. The symbol d2y upon dx2 is not dy upon dx whole square. It is not a square. Many people read it square. Make it clear. It's d2y upon dx2. Square actually is something else. Square is actually something else. And this is a point where you should remember that it's a symbol. It's not a power 2. You have to copy the left-hand side also.
Done.
When you differentiate a function second time, it's very simple that you differentiate it once and then you differentiate it twice. You will get the second derivative. Remember the symbol f double prime x, y double prime. So these are the symbols. Copy this example in notes.
Done.
So this is how we differentiate the function second time. I have given you one more example and you can see what is the difference. I want you to highlight the symbol. Many people in the paper forget this symbol. Many people know the symbol D, D2y, dy, but F prime X, F double prime, which I have made it red. So highlighting that this is also an official symbol for derivation.
All right. Done.
Generally, a quadratic function has a maximum or minimum value. Normally, when you talk about a quadratic function, quadratic means power of x is 2, like x square, like y square. It's a quadratic function. A quadratic function has a power of 2, has a maximum or minimum value. Now, you have to copy this screen.
Done.
In a quadratic function, copy this.
Done.
Look at the shape of the graph. There are two graphs. One is called maximum curve, which is a sad face, and one is called minimum graph, which is the smiley face, the TP. TP stands for turning point. You have to copy these two shapes.
Done.
TP is called turning point. The second name for turning point is a stationary point. The second name for turning point is stationary point. You have to copy this.
Done.
Now make the concept. Gradient at the turning point is always zero. So whenever you are at the turning point of any sketch, the gradient is zero. You have to copy this.
Because it's horizontal. Huh?
Can you repeat the question, please?
Is it because it's horizontal?
Yes, very good. Because it is parallel to x-axis. In physics, if a line is parallel to x-axis, its gradient is zero.
All right, done. Done, sir. Sir, can we discuss that question that I sent you because I'm having a bit of problem with that?
That question is simple. We should save the time. I have already sent you the previous solutions, right? So that question is very simple. I will try to send you a short video or picture. You can first see the solution I've already sent you, right?
I did see those solutions, but they are not really matching with this question. This question is sort of different. The
So I
part 12.
try to understand that that question is actually in the same background. If you have the question in front of you, you just look at the question. Remember, whenever there is a fraction, LCM is the starting thing. Okay, whenever there is a fraction, so can you see the fraction is sine theta plus 1 and sine theta minus 1? Can you hear me?
Yes.
So take the LCM. At turning point, gradient of tangent is 0 because the line is parallel to x-axis.
Yes. Then
In order to find maximum or minimum value of a function, differentiate it and put it equal to 0. This is the core concept. This is the main concept of this chapter. When you want to find maximum or minimum value of a function, differentiate it and put it equal to 0. Solve it.
then I'm done with this, sir.
Now, let's make the steps. Number 1, find dy upon dx. Step number 2, dy upon dx equal to 0 and find x. The x will belong to stationary point. Put x in the given equation to find the stationary point. Copy these steps.
Done.
Now, copy these steps also.
Done.
There are three types of functions. One is called maximum, second is called minimum, and the third is called inflection, which is not required in any detail. So you have to copy this distribution of types of functions also.
Done.
Now we keep it up to here, and now you have homework again, and I've sent you some material today also. So please try to give that work, and also the same thing to remember, which I have been